What is dynamometer? In a dynamometer, there are two blocks or two bodies of different masses, and that two bodies will be connected by a spring, and that is a dynamometer. So there will be two blocks which will be connected by a spring, and this is called dynamometer, which is an instrument and it is used to measure force, torque or power. M1 and M2 are the masses of the two blocks or two bodies in a dynamometer, and the body of mass M1 is pulled with a force F1. A body of mass M1 is pulled with a force F1. Similarly, the other block or the other body of mass M2 is also pulled by applying a force F2 towards left, and this is a dynamometer. This is a dynamometer. Dynamometer is a device. Dynamometer is a device which is used or which measures force, torque and power. Dynamometer is a device which measures force, torque and power. It will read the force. It will read the force by which it is stretched. It will read the force by which it will be stretched or it is stretched. Let F1 and F2 be the two forces which are applied to the blocks or to the bodies of masses M1 and M2 respectively, attached to the spring of the dynamometer. Let F1 and F2 be the two forces which are applied to the blocks of masses M1 and M2 attached to the spring of the dynamometer to stretch the spring. If the tension appears as action at the end of the spring to which the block of mass M1 is attached, if the tension T appears as action at the end of the spring to which the block of mass M1 is attached, the same tension, that is T, will act as reaction. Same tension T will act as reaction to the left end of the spring, of the dynamometer to which the another block or another body of mass M2 has been attached or is attached. Here A, B, the common acceleration of the two bodies of masses M1 and M2 towards right under the action of the two forces F1 and F2. Here what we can write, both the blocks will be moving with the same acceleration or with the common acceleration A, in the direction of the greater force F1. Here F1 is greater than F2. Considering the motion of the block of mass M1. The net force acting on the block. The net force acting on the block of mass M1 in the direction of the applied greater force F1 is given by M2 dot A, that is mass into acceleration is the net force, which will be equal to F1 minus T, which is equation 1. M1A is the net force acting on the block of mass M1. Here for M1 is moving with acceleration A towards right, and resultant force is M1A, and there are two forces F1 and T. So M1 dot A will be equal to F1 minus T, that is the net force acting on the block of mass M1. Here the block M1 will be moving with an acceleration A in the direction of force F1 and net force acting on M1 will be what? F1 minus T, which will be equal to M1A. That is the net force acting on M1. Similarly, the net force acting on the another block of mass M2. Net force acting on the another block of mass M2 is given by the net force acting on the another block of mass M2 in the direction of the greater force applied to the another block of mass M1 is given by m2 dot a, that is mass into acceleration, which will be equal to t minus f2a. Here T and F2 are the two forces experienced by the second block of mass M2. So net force acting, and here M2 will be moving with an acceleration A, and net force acting on M2 will be what? M2 dot A, which will be equal to T minus F2. Dividing the equation 1 by 2, we get, dividing the equation 1 by 2, we get M1A divided by M2A M1A divided by M2A is equal to F1 minus T divided by T minus F2, or comma M1 by M2 or comma M1 by M2 is equal F1 minus T divided by T minus F2, or comma M1T minus M1F2 is equal M2 F1 minus M2T, or comma M1T plus M2T is equal M2 minus M2 F1 plus M1 F2. Therefore T is equal M2 F1 plus M1 F2 divided by M1 plus M2. T is equal M2 F1 plus M1 F2 divided by M1 plus M2. This is the tension acting in the spring connecting the two blocks of mass M1 and M2 in a dynamometer. This is the reading, and this is also the reading of the dynamometer. If a greater force F1 is acted towards right on the dynamometer and a smaller force F2 is acted towards left, in that case, under the action of these two forces F1 and F2 such that F1 is greater than F2, then the two blocks in the dynamometer will be moving with the common acceleration in the direction of greater force. Two blocks of masses M1 and M2 in the dynamometer will be moving with the common acceleration A in the direction of greater force. Here the mass M1 will be moving with an acceleration A. Similarly, the block M2 will also be moving with the same acceleration A. In this case, reading of the dynamometer will be is equal to the tension acting in the spring. Here reading of the dynamometer is T. T is the tension acting in the spring, that is the reading of the dynamometer, and T is equal to M2 F1 plus M1 F2 divided by M1 plus M2. That is the reading of the dynamometer.